questions 11 through 20 on the 2013 Grade 7 Gauss Math Contest. The length of a cube edge is 1 centimeter. The surface area of the cube is. A cube, as you are well aware, has 6 faces, correct? And the length of each side they're saying is 1. Length times width times height will all be the same for a cube. And therefore, each face, here's one face, will have an area of just 1 times 1. Now there's 6 faces in a cube, so to get the total surface area, we have to look at all 6 faces, so 6 of those areas, and that would be 6 times 1 times 1, and that is just 6 times 1, which is equal to 6. So the total surface area of the cube is 6, and therefore number 11 is E. Which of the following pairs of numbers has the greatest common factor of 20? So we've got 200 and 2000, and then we've got 5 other pairs. So how do you figure out the greatest common factor? What does that even mean? Well, it means the greatest number that can factor into both numbers. Okay? So for example, in this first scenario, the GCF, greatest common factor, is 200. Because 200 can go evenly into 200, obviously, and also into 2000. 2000 divided by 200 is 10. So that's the GCF. Now, this next one, not as easy, right? You say, well, I'm wondering what this is now. Well, there's a quick way and a fast way. The quick way is just through inspection. The slower way is to break up each into its prime factors. So I'll do that just for purposes of explanation. 40 is equal to 2 times 2 times 2 times 5, right? 8 times 5. 50 is equal to 2 times 5 times 5. So when you break it up into 5 prime factors, what you have to find is what's common to both. Is 5 common to both? Yes. Is 2 common to both? Yes. But then, is this another 2 common? No, because there's no 2 here. And there's no additional 2. Is this 2 common here? No, because there's no more additional 2. And same thing, is this 5 common? No, because there's no more 5s there. So the only thing that I could circle that's common to both was the 2 and the 5. And then what you do is you multiply those. This is therefore your GCF. So whether you did it by inspection or through the long way, either way you have to figure out the GCF. So for the next pair, the GCF is 20. That's done easily through inspection. This one, well, I can do it by inspection, but I'm not trying to brag. But the key thing is when you're not sure, just break it up into its prime factors. And when you do, you get 2 times 2 times 5. And 25 is just 5 times 5. So again, what's common? The 5 is common, and that's it. So the only thing that I can find that's common between those two is 5, and therefore that's the GCF there. And then finally, for the last one, the GCF is 40. So they're saying which one of those has a GCF of 20, and that would be these guys. So the answer for number 12 is C. Jack, Kelly, Lan, Mihai, and Nate are sitting in the 5 chairs around a circular table. Lan and Mihai are sitting beside each other. Jack and Kelly are not sitting beside each other. The 2 people who are seated on either side of Nate are. So we have a circular table, and we've got these 5 friends. Now they told me that Lan and Mihai are sitting beside each other. So Lan is here, Mihai is here. They're sitting beside each other. Then we've got 3 friends left. Those 3 friends are Nate, Jack, and Kelly. And they told me that Jack and Kelly are not sitting beside each other. So if Jack is here, Kelly's got to be here, and in the middle between Jack and Kelly has to be Nate. That's the only way to arrange these 5 friends according to the information in the question. Now, the final sentence asks, the 2 people who are seated on either side of Nate. Well, here's Nate. Who are the 2 people on his either side? J and K, Jack and Kelly. So number 13, the answer is B. If x equals 4 and 3x plus y is 30, what is the value of y? So x is 4, 3x plus 2y is 30. So here we go. We've got 3 times 4 plus 2 times y is 30. So this is 12 plus 2y is 30. So 2y is equal to 30 minus 12, which is 18, and therefore y is equal to 9. So number 14, the answer is E. Daniel begins with 64 coins in his coin jar. Each time he reaches into the jar, he removes half the coins that are in the jar. How many times must he reach in and remove coins from his jar so that exactly 1 coin remains in the jar? Initially, he had 64. Every time he reaches in and takes out half, so he'll take out 32, 32 will remain. Then he reaches in, takes out half, which is 16, 16 will remain. Then he reaches in, takes out half, which is 8, 8 will remain. And so on, 4, 2, and then 1. So they're asking how many times did he reach in the jar? This was the first time, second time, third time, fourth time, fifth time, and sixth time. Each time he reached in the jar, he took out half, and the next number is what's remaining. So they're saying how many times does this happen before we get to the scenario where only 1 coin remains? Well, 1, 2, 3, 4, 5, 6 times he had to reach into that jar and repeat the process. So number 15, the answer is 6, which is C. The mean average of 5 consecutive even numbers is 12. The mean of the smallest and largest of these numbers is. Okay, you can do this by inspection, or you can do it the long way. I'll do it the long way, why not? They're even numbers, so they're of the form 2n, 2n plus 2, 2n plus 4, 2n plus 6, and 2n plus 8. Those are 5 consecutive even numbers. And they're saying that when you add them and take the average, so there's 5 of them, that result will be 12. So let's do the math. Cross multiply, 12 times 5 is 60. And then when you add these guys, 2, 4, 6, 8, 10, 10n. And then we add the numbers 2, 4, 6, 8, what's that? 20. So there we go. Subtract 20 from both sides, and we get 40 is equal to 10n, and therefore n is equal to 4. So n is 4, okay? They want the mean of the smallest and largest. This is the smallest number, and this is the largest number. So if n is 4, this is 8, and this would be 2 times 4, which is 8, plus 8 is 16. So they want the mean of those two numbers. Okay, no problem. 8 plus 16 divided by 2 is 8 plus 16 is 24, divided by 2 is 12. So that's the answer, 12. Interestingly, is the same as that. Number 16, therefore, the answer is A. For every 3 chocolates that Claire buys at the regular price, she buys a 4th chocolate for 25 cents. Claire buys 12 chocolates in total for $6.15. What is the regular price of 1 chocolate in cents? Okay. We have a scenario where she's going to buy 3 at regular price, and then the 4th one for a quarter, 25 cents. And she's buying 12 in total, right? So that's 4. Got another 4 and then another 4. So P, and then 25 cents, and another 3 P's, and then 25 cents. So this is the scenario for the 12 chocolates. Now, when you add all these up, it's got to equal $6.15. Okay, we can make an equation. All these P's added together, there's 9 of them, right? 9P. And then 3 times 25 cents, and that's got to be $6.15. So 9p plus 75 cents, or 0.75, is 6.15. Subtract from both sides. So what is that, 540? Yeah, 540. And then 540 divided by 9 is 60.6, which is basically 60 cents. And that means the regular price, which I represented by P, was 60 cents. So number 17, the answer is C. JKLM is a square and PQRS is a rectangle. If JK is parallel to PQ, JK is 8, PS is 2, then the total area of the shaded region is. Well, the shaded region is a nice little square, like that. And then what they've done is they've cut out a segment like that. And then they've said that this is the shaded region here. Okay, well, that shouldn't be a problem. They told me that JK is 8, so that doesn't change. But this part is no longer 8. It was 8, but now we've got to cut out this part. So that part they're saying, which is PS, right here, is 2. So this is 2, but this is 2 also. Okay, so basically it's a scenario of the full square, which is 8 times 8, minus this little guy in here, which would be 8 times 2. So that's 64 minus 16, and that's 48 for the shaded region. And that's it. So number 18, the answer is D. A special 6-sided die is rolled. The probability of rolling a number that is a multiple of 3 is a half. The probability of rolling an even number is a third. A possibility for the numbers on the die is. Okay, so the probability of rolling a number that is a multiple of 3 is a half. A half is the same as 3 over 6. Now the reason I put it like this is because there's 6 numbers. So that means 3 of those 6 numbers are going to be multiples of 3. Let's go through the answer choices. 3 of the 6 numbers must be a multiple of 3. Okay, how about A? Do we have 3 multiples of 3? We only have 2. So A is not one of the answers. How about B? Do we have 3 multiples of 3? We have 3, 3, and 6. Yes, we do. So we keep B. How about the next guy? We have 3, 6, and 6. Those are all multiples of 3, and there's 3 of them. That's good. How about D? We have 3, 3, and 6. Okay, we keep D. E. We have 3, 3, 3, and 6. We have 4 multiples of 3 here, so that's no good. Okay, so I've narrowed it down to B, C, or D. Now let's look at the next criteria. The probability of rolling an even number is a third. So a third, I'm going to convert that to 2 over 6. That means that 2 of the 6 numbers have to be even. Okay, let's see now. 2 of the even numbers, so 2 of the 6 numbers have to be even. Okay, so here we go. Looking at B now. Do I have 2 even numbers? I have 2 and 6. Yeah. Okay, so B is right. But let's look at C and D. Do I have 2 even numbers? I have 1, 2, 3, 4 even numbers there. So that's wrong. How about D? Do I have 2 even numbers? I have 1, 2, 3 even numbers. So that's wrong. So the criteria of the question is fulfilled only by B for number 19. Toothpicks are used to make rectangular grids as shown. Note that a total of 31 identical toothpicks are used in the 1 by 10 grid. How many toothpicks are used in a 43 by 10 grid? Okay, well, you're obviously not going to draw out 43 by 10 grid. So we have to come up with some sort of a pattern. The pattern is not too difficult. First, let's just look at the 1 by 10. When you have a 1 by 10, you can clearly see that you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of those sticks that are vertical. So the reason it was 11 is because it's 10 plus 1. Okay? So we have 11. But how many of those rows are there? Well, there's just only one row. And in this case, it was 1. So 1 times 11. But then we also have to count the horizontal ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of those. So we have to add to that 10, but we have to add both rows. So 2. This is how I have to figure this out. So that's 20 plus 11, which is 31, and that's what they told me in the question. Okay, so far, perhaps I don't know what the formula is, because eventually I want a formula for n times 10, and I can use that to figure out 43 times 10. Okay, here we go. Next one. I've got to put, again, same sort of story, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, but this time I've got to do that twice, right? Okay, so 11 times 2. And then I've got to add to that all these horizontal ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I've got to do that 3 times. These guys, and these guys. So it's going to be 3 times 10. And then there was that 2 times 11. And then what does this equal? 52. Okay, let's just do one more and hopefully you'll get a pattern. For the next one, same sort of story. It'll be 4 times 10 plus 3 times 11. And that turns out to be 73. Okay, now let's try to figure out a general formula for n times 10. As I hope you can see so far, it will be n plus 1 times 10 plus n times 11. That is my general formula. And I hope, because I gave 3 examples, that you can see how I came up with that just by following that pattern. Okay, so if you're convinced that this is the formula, let's plug in 43. So 43 times 10, that kind of a grid. And n is now 43, so it would be 43 plus 1 times 10 plus 43 times 11. So this is 44 times 10, which is 440. 43 times 11 is 473, and then adding those together, you get 913. So 913 toothpicks are used in a 43 by 10 grid. So number 20, the answer is A.